done. We got to chapter 5. Got to chapter 5. We're going to call this one, it's going to be 5.1 is how we're going to start. But we're going to kind of do a little mix of 5.1 and 5.2. So we're going to think of this as kind of sitting in the same spot. I'm not going to really differentiate too much. I mean, I'll give you little alerts and this, that, and the other. But we're going to kind of streamline this, like we said in class. We want to get the basics of it. We're not going to spend too much time playing like little games. We want to get a nice, good, basic overview as to what the hell's going on, and then get some tools so we're going to be able to get into Calc 2 and just off and running, ready to go. So we start with the area under the curve. Our big question in Calc 1 when we started was, what's the slope like right here? You know what I mean? And then we had to go in and find some fancy way, which we called the derivative. We took limits and all this other bullshit. But now we're asking, how do you find the area underneath a curve where it's curved? You know what I mean? If this was just a triangle, I mean, if we had something that was just a triangle, well, shit, we could go and find that, no problem. We can use our geometry and our trigonometry skills, and we're off and running. But what do we do when it's a curve? Now, this is our Calc 2 thing. I mean, I'll spoil it right now. It has everything to do with integration. But we're not allowed to do any integration yet. We have to get there. We have to build ourselves up before we're allowed to. Just like you have to do limits before you can do derivatives, it's going to be the same thing. We got to do a little bit of messing around. You got to see the summation. You got to get accustomed to it. You're going to see some shit like this, the weird E, and there's going to be indices in here, n equals 1. Maybe we'll go to infinity. Maybe we'll mix that shit up with limits. But first, just what the hell's going on? And let's get into that. So we want to find what's this area underneath there. And the way we're going to begin, and the way that people figured it out back in the day, is they just estimated it first. So we could just make a couple rectangles. So what we have on the left-hand side here is what we call a left hand one. So we're just going to take the rectangles of wherever our left-hand point is. We break it into 4 little intervals here. We've just broken into 4 rectangles. Just 4 little rectangles, so we can have, you know, just like this. 5 points, but we broke it up into 4 rectangles. And we chose the point from the left. And then the point from the left. And the point from the left. And then the point from the left. And we just looked at this area. And you can see this is a terrible approximation, isn't it? It's going to be way under. It's not going to be right. It's going to be way under. It doesn't seem like a very good thing, but this is what you're going to do. I'm going to set you up and have you do a couple of these where we're going to call this as we get going n equals 4. We're going to say we're going to break this into 4 of these little rectangles. What have we been doing with n's? Never mind. Let's just move forward. And then we have it on the right. The one. Well, this is from the left. Let's look at the one on the right, where we're taking our points on the right. And we're doing one of these, just kind of making a little rectangle. And gosh, this is just a gross overestimate, huh? That's just way too much. It's like what it should be would be in between the two, right? So I think the area is somewhere in between this. So this is n equals 4. So we'll actually call this R4. We'll call this L4. And we'll say the true area, well, it's somewhere in between these two things. L4 meaning we're coming from the left, taking all our points from the left. We're just doing 4 of them, n equals 4. It's kind of like how we write it up, this little subscription. We can say that our actual area, our true area, is somewhere in between the two of them. There's got to be a way. Well, there is a good way. And what we have is, let's go look at good old Desmos. And we're set up, and here's our situation. And this is from the left, right? Not right, left. Left. It's from the left, all our points. Notice it starts at 0. It's the underestimation, right? It's the underestimation. It's this one over here. Okay? Well, that's with making 4. good old Desmos here, have everything set up, we can change how many we have by hitting the end. So if we make more of these little rectangles, oh shoot, look at our estimation. That estimation is getting dope. It's not bad. You keep this thing going, you can barely even see that there's the little white dots in there. And that's only 100. Let me tell you, infinity's a frick of a lot bigger than 100. That estimation isn't going to just be close. It's not even going to be an estimation. I think if we can take that concept and take it all the way out to infinity, shit, we might have the exact area. You know, limits might have something to do with this. Let's just things go to infinity. But as we see, when we have less, we get a shittier estimation. Look at 2. 2 of them's great. Look at 1. Oh, geez, you don't want to look at those negatives. There's none of them. There's 1 of them. There's 2. All right, see, playing around with Desmos. All I did was typed in Riemann sum in Desmos, and this fun little thing popped up. So here's a little bit of an intro. This is what we're going to be doing. We'll be messing around with finding left-hand sums and right-hand sums. We'll be using summation symbols so we can get used to what all this stuff means. So really, you're going to be adding up the area of frickin' rectangles. That's all we're going to be doing. Your homework through 5.1 is add up areas of rectangles. By the way, it's base times height. Shh, don't tell anybody. That's all you're going to be doing. Breaking them up into equally spaced things. Equally spaced things depending upon how many we tell you to. Break it into 4, break it into 8, break it into 6. Let's do some sines and cosines and look at that shit. Cool. See you in the next one.